Today we will have a lecture on that is engineering mechanics. So already we have solved the numericals in which the block, this is nothing but actually a block which has been kept on an inclined plane, and this force it has been applied on this block, whereas again a force, upward force in the form 1200 Newton, it has been applied in downward directions. Okay, so same type of numericals we have solved in previous lectures. So those who have not seen the previous lectures, go through that previous lectures so that the concept will be clear. Again we will solve some more problems in which we will find out x and y intercept or x and y component of these forces. So here in this case two forces are applied on this block. So there is an inclined plane, this is nothing but an inclined plane. Okay, so this inclined plane it has been making an angle of theta, but theta to be calculated. So how to find out theta? The opposite upon adjacent, 3/4. Opposite side is 3, whereas adjacent side is 4. So we can find out this theta, but this problem is a little bit it is simple as compared to the previous problem. Why? Because this theta is directly transferred here and it has also transferred here. Okay, so it is a very simple way in order in which we can find out the theta. Once we have calculated the theta, the same theta will be transferred here for the force 400 Newton, and the same it has been transferred theta here for 1200 Newtons. So which things to be calculated in this today's problem? We are finding out the x and y component. Okay, this is nothing but the figure in which we are finding out x and y component. Again I am repeating this. We have to see in such type of problems, when there is an inclined plane or any other problem, we have to first specify along which x and y axis we have to resolve all the components. Okay, so we have to resolve f force and p force along x and y component, but it is a little bit as usual, it is different. X and y component is different. X component is parallel to this plane, that means we have to resolve the forces along this plane. So this parallel to this plane is nothing but x component. Okay, parallel to this plane is x component. When it is moving upside, or when that arrow of that force is upside, it is positive. When the arrow of that force is downward, it is negative. Okay, same way when y component it is perpendicular to this plane, it is perpendicular to this plane. Okay, this y component is perpendicular to this plane. Okay, when it is in upward direction it is positive, when y component is in downward direction it is negative. Okay, so in this way we have to solve the problem by considering the x and y component. X is parallel to this plane, that is the inclined plane, and y is perpendicular to this plane. Okay, upside is positive, downward is negative. This upside is positive and this downward is negative. Okay, so in this way we have to first find out the angle. Okay, so first we will find out this theta, so that this theta will be used here and this theta will be used at this component. Okay, so we have to find out the theta for this solutions. So we will find out first of all the theta. Okay, so theta is equals to, simple formula is there, theta is equal to tan inverse of opposite upon adjacent. So tan inverse of opposite is 3 and adjacent is 4. Okay, so how much is the angle? The angle it comes to be 36.86 degrees. So tan theta or theta is equals to 36.86. The angle made by this plane is 36.86. The same angle it has been transferred for the force F. The same angle it has been transferred for the force 1200, that is P. Next we will resolve all the forces simple way along x and y component. We are resolving the forces along x and y component. So I will resolve the forces along x and y component. So first while resolving, one thing it is to be kept in mind. Suppose this pen is the force. Okay, this is 400 Newton is the force. The tip of this is the arrow of the force. The tip of my pen is the arrow of the force. Again, while resolving we have to see, first we have to resolve along x and y directions, or first we have to resolve along the angle. So here the angle it has been made along the x-axis. Here the angle it has been made along with the x-axis. So first we will resolve along x-axis. That means this component is cos theta. Again we have to reverse the force in original positions. Okay, then y component. While resolving, this concept is to be clear. So we have to keep the force in original positions. Okay, this is the original position. Okay, first we will resolve along the angle which has been made. The angle here, it has been made with x-axis, so we will take the x component first, x. Okay, then it is original force, then it is y component. So y, it is downward, y it is downward. But what about x? X is upside. Okay, so here we will resolve this force along x and y component. So this is force F. So I am directly without force F. We will have the its intensity 400 is the force. It is making an angle of this, so it is cos theta. Okay. Again, this force, (400) sin theta. Okay. What about the next force? Force is 1200 newtons. The next force is 1200 newton. Again, this force is perpendicular. Sorry, this force is vertical force, but it is moving downwards. Okay? So here the angle made theta with this y-axis. Here is the y-axis. Okay? Here is the y-axis. So along which plane it is making an angle? The y-axis. So first we will resolve along y-axis. So this will be the first y component. Okay, again its original position, and again its original position, and this will be the x component. Okay, this will be its x component. So this is the original force. The tip of my pen is the downward force. So this will be its that is the y component. Again original force, then resolve along these directions. This is nothing but the x component. Okay, so one thing it is to be kept in mind while resolving along x and y component, we have to place the we have to imagine the force in its original position, then resolve. Okay, so this is nothing but x component and original force, sorry, y component and original force and x component. This means these are the two forces. So I am resolving these forces. Yes, so this force, this is 1200, but here this angle made with the vertical. So okay, but this component is cos theta, and this component will be sin theta. Okay, so up to this the concept is clear. So I have drawn the figure for this. It is very simple concept is there, in which we have resolved the forces along x and y components. Okay, so it is the resolution of forces, or the problems related with the resolution of forces is very simple concept is there. There is no as such confusion regarding the how to find out the x and y components. Okay, so first we have calculated the theta, then we have resolved this 400 Newton along x and y directions, then we have resolved 1200 along x and y directions. Okay, so then we will find out all the x components and all the y components. Okay, or which to find out the x and y component, the first force we have to find out x and y component. Okay, so 400, or first force is F force, x component, Fx. What is the x component for this force? So x component is, x is this direction. The 400 x component is this upside, 400 cos theta. 400 cos theta is the x component. 400 cos theta, so 400 cos of 36.86. So we have calculated the x component. Okay, what is the value for this Fx? Fx is 320.04. You can tally the answers. Okay? You can tally the answers. You can use the calculators for this, as I am having the answers. So we will write down directly. you can calculate these answers. Same way y component for the force F. Okay, so this is the y component for the force, but here it is upside directions. But my for the force F, what is the y component? It is in downward directions. So we will have minus sign. 400 sin theta minus 400 sine of 36.86 degree. So Fy, y component for this force is 239.94 newtons. Okay. Next is again P force x and y component. So Px x component. Okay. X component in this case is this. This is the x component, but it is in downward directions. So minus 1200 sine theta. It is 1200 sine of 36.86. The px value with minus sign is 719.83 newtons. So this is nothing but the x component of this force. Y component. Yes. What about this y component? Y is also minus. Why? Downward directions. Minus 1, 2. With minus cos of 36.60. So it comes to be, what is the y component for this force? Minus 960.12 newtons. So in this way we have calculated its x and y component. Okay? Now in this way we have calculated the x and y component for this force. So here this problem, it has been ended, in which we have calculated x and y component of all these forces. So for force F, what is the x component? It is 320 plus sine 320.04 newtons. What is the y component for this force F? It is with minus sign. Okay? Y component is with minus sign. 239.94. Px x component for this is minus 1200 sine of 36.86 to minus 719.83 newtons. Y component is minus 960.12. So in this way we have calculated, or we have find out the x and y component of the forces. Okay.